Beneath the dark, restless waters of the North Sea lies a secret, a structure hidden under layers of chalk and clay, invisible to the eye, yet vast in its implications. For decades, oil companies probed these waters, searching not for cosmic scars but for hydrocarbons. And in their seismic maps they stumbled upon something extraordinary, a near-perfect crater with concentric rings like ripples frozen in stone. But was this the work of an asteroid screaming in from the void, or the slow crawl of Earth's own geology? For 20 years, scientists argued. Now the answer has finally been revealed. This is the story of the Silverpit impact, the hidden catastrophe that struck Britain's doorstep 45 million years ago. To understand Silverpit, we must go back to the Middle Eocene, around 43 to 46 million years ago. The world was warm, much warmer than today. Palm trees grew near the poles. Crocodiles swam in the swamps of what is now Germany. Antarctica still had forests. The North Sea itself was not the cold, grey expanse we know. It was a shallow, tropical basin teeming with life. Small whales and archaic dolphins swam above. Giant birds with teeth patrolled the skies. The seafloor was covered in chalky sediments laid down by countless microorganisms. It was into this world, lush, hot, alien, yet familiar, that an object from deep space arrived. A rock the size of a city block, travelling faster than a bullet. Its destination, the seabed, that would one day become Britain's frontier. The story of Silverpit begins not in prehistory, but in the early 2000s. Oil companies exploring the North Sea collected vast 3D seismic datasets, essentially underground X-rays of the seabed. In 2002, geoscientists analysing the data saw something bizarre. There, beneath 700 meters of sediment, was a near-perfect circle 3 kilometers across, with rings extending outward like a target. The discovery stunned the scientific world. Britain, it seemed, might be sitting on its first known impact crater. Newspapers ran with the story. The North Sea had its very own British Chicxulub, though far smaller in scale. The structure was named after the nearby Silverpit fishing grounds, but its origin was far from settled. But almost immediately controversy erupted. Not everyone believed the Silverpit structure was an impact crater. Some geologists argued it was simply the result of salt moving deep below the seabed. The North Sea is riddled with zechstein salt deposits, ancient layers that can flow and deform like glaciers underground. As they shift, they can drag sediments with them, creating circular depressions and faults that mimic craters. At first glance, Silverpit looked like a textbook impact. But without direct rock samples showing shocked minerals, the case was circumstantial. For years, conferences became battlegrounds. In 2009, the Geological Society of London even held a formal debate. The vote? The majority sided against an impact origin. Silverpit, they declared, was probably just a quirk of geology. And so the mystery deepened. Was this a cosmic scar or a geological illusion? When modern seismic scans peeled back the seabed, the Silverpit crater revealed itself in astonishing detail. At its heart lies a central uplift, a dome of rock pushed upward by the rebounding force of the impact. Surrounding it, an annular moat dips down, like a trench encircling the uplift. Beyond that are concentric rings formed as the ground fractured outward, freezing the ripple pattern of impact into stone, and lacing through it all are faults, some curving like petals, others slicing radially outward. Even more telling, the crater is not symmetrical. The central uplift is offset, the fault patterns distorted. These asymmetries reveal the truth. The impact came not straight down, but at a low angle from the west-northwest. The result is a structure preserved with exquisite clarity, sitting like a fingerprint of catastrophe beneath the North Sea. But patterns in rock can mislead. Geology can imitate an impact. What it cannot fake is shock. In 2025, new studies re-examined drill cuttings from a nearby well. Under the microscope, they found quartz and feldspar grains unlike any formed in normal Earth processes. These minerals bore scars, planar deformation features, tiny glassy lamellae formed only under pressures of 10 to 15 gigapascals. That's 100,000 times the atmospheric pressure at sea level, conditions achievable only in a hypervelocity impact. This was the smoking gun. No salt dome, no tectonic shift, no earthly process could explain minerals altered in this way. Silverpit at last had proof of an extraterrestrial strike. So what exactly struck the Eocene seas? Numerical models suggest a rocky asteroid around 160 meters wide, the length of 2 football fields. Entering Earth's atmosphere at 15 kilometers per second, it slammed into the seabed with the force of nearly 200 megatons of TNT. That's about 4 times the energy of Tsar Bomba, the largest nuclear device ever detonated. The crater that formed, just over 3 kilometers wide, seems small compared to earth-shattering giants like Chicxulub, which measured 150 kilometers across. But size isn't everything. Silverpit's impactor carried enough power to devastate the shallow sea, churn the water into chaos, and trigger tsunamis towering like skyscrapers. The immediate aftermath was apocalyptic for the Eocene North Sea. The impact blew a column of water skyward, vaporizing seawater in a blast of steam and fire. The crater gaped open, then the sea rushed back in, collapsing into the void. This resurge didn't simply refill the basin, it rebounded violently, generating waves that circled and sloshed for hours, perhaps even days. Models suggest that near the crater rim, waves may have reached 100 meters high. That's taller than the Statue of Liberty, smashing outward in a breaking wall of ocean. Whether these tsunamis reached the Eocene coastlines of Britain, Denmark, and Germany is still debated. But for marine life in the basin, whales, birds, and shoals of fish, there was no escape. The sea itself became a weapon of destruction. Silverpit struck a world alive with creatures both strange and familiar. The Eocene was an age of transition. Primitive whales, long-snouted, crocodile-like archaeocetes, hunted in warm coastal seas. Giant flightless birds stalked the shorelines. Tropical fish swam in dense schools, while vast blooms of microscopic plankton carpeted the water column, their chalky shells raining down to build the very seabed. An impact in such an ecosystem was catastrophic. The immediate blast zone sterilized everything. Fish boiled alive, plankton annihilated, birds and reptiles flung aside by the shockwave. Farther afield, life endured. Unlike the extinction-level Chicxulub strike, Silverpit was a regional disaster, not a planetary one. Yet in that corner of the Eocene world, an entire marine community was wiped out in a single day. After its discovery in 2002, Silverpit ignited a firestorm of debate. Impact craters on land are often easy to prove. You can walk up to the rocks, split them open, and search for shocked minerals. But under the sea, beneath hundreds of meters of sediment, certainty is harder to come by. Almost immediately, skeptics proposed alternatives. They argued the structure was not an impact, but the result of salt movement deep underground. By 2009, the Geological Society of London staged a formal debate. The hall filled with geologists, each side making its case. When the votes were counted, the majority sided against an impact origin. For years, Silverpit was dismissed as a geological curiosity, interesting but not cosmic, and yet some scientists refused to let the mystery go. They believed the crater held secrets, waiting for better technology to reveal them. Their persistence would eventually change the verdict. In the decades after the debate, technology advanced. High-resolution 3D seismic surveys became sharper, faster, and cheaper. The Silverpit structure was re-imaged in unprecedented detail. Suddenly, features blurred in earlier scans came into focus. A central uplift, concentric faults, radial fractures, asymmetry that revealed an angled impact from the west. This was no salt dome. The patterns were too precise, too diagnostic. Finally, geologists examined drill cuttings once more, this time with modern microscopes. In the quartz and feldspar grains, they found the unmistakable signs of shock metamorphism. The case was closed. In 2025, a landmark study announced the result. Silverpit was indeed an impact crater. After 20 years of doubt, the cosmic origin was proven. Yet even now, Silverpit holds mysteries. How far did the tsunami waves travel? Did they crash onto the Eocene coastlines of Britain, Denmark, and Germany? The evidence may still lie buried in coastal sands, waiting to be uncovered. Where is the ejector, the blanket of debris thrown from the crater? Only a few grains of shock minerals have been identified. Somewhere, perhaps in cores drilled elsewhere in the basin, lies the wider fingerprint of the blast. And what of the impactor itself? Was it a stony asteroid or a fragment of a comet? Its low-angle strike complicates the models, and the exact speed and trajectory are still uncertain. For all we know, Silverpit may have been part of a larger episode of bombardment, one impact among many in the turbulent Eocene skies. On the surface, Silverpit seems small, a 3-kilometer crater buried beneath the North Sea. But in science, size is not the only measure of importance. Silverpit is one of the best-preserved marine impact craters on Earth. Most such craters are quickly eroded or buried beyond recognition. Here, under layers of chalk and clay, the structure was sealed away, waiting for technology to uncover it. For Britain, Silverpit is unique. It is the first confirmed asteroid impact crater near the UK, revealing that this island's history is tied not just to tectonics and erosion, but also to the violence of space. Globally, it helps scientists refine models of what happens when a medium-sized asteroid strikes a shallow sea, an event far more likely to occur in our ocean-covered world than a direct hit on land. Silverpit joins a small catalogue of marine impact sites. The Chicxulub crater in Mexico, 150 kilometers wide, ended the age of dinosaurs 66 million years ago. The Nadir crater off West Africa, discovered in 2022, is similar in size to Silverpit and may have formed in a cluster of Eocene impacts. Compared to these giants, Silverpit seems modest, but it fills a critical gap in our understanding. It shows what happens when a smaller asteroid, hundreds, not thousands of meters wide, hits an ocean basin. Such strikes may not end worlds, but they can devastate regions, trigger mega-tsunamis, and reshape local ecosystems. In terms of probability, these medium-sized impacts are the most likely cosmic hazard our planet faces. Silverpit is not just a window into the past, it is a warning. The asteroid that struck the North Sea was only 160 meters wide. If such an object were detected heading for Earth today, it would rank as a high-priority threat. A direct hit on a major ocean could generate tsunamis that imperil millions along the coasts. Modern surveys track thousands of near-Earth objects, but many medium-sized asteroids remain undetected until they pass close. In 2013, a 20-meter asteroid exploded over Chelyabinsk, Russia, injuring over 1,000 people, and no one saw it coming. Silverpit reminds us that even smaller strikes can be catastrophic, and it underscores the urgency of planetary defense. Telescopes to spot threats early, and missions like NASA's DART that prove we can nudge an asteroid off course. The past is not dead, it is a rehearsal for the future. Beneath the waves of the North Sea, a scar lies hidden, the frozen memory of a day when fire fell from the sky. For nearly 20 years, scientists argued whether Silverpit was an impact or an illusion, but now the evidence is clear. Shocked quartz, a central uplift, concentric faults, a crater sealed beneath the seabed, testifying to the violence of the cosmos. Silverpit may not have ended an era, but for a brief moment in the Eocene, it transformed an entire sea into chaos. It reminds us that Earth's history is not only written by ice, fire, and tectonic, but also by the silent messengers of stone that wander the void. And it forces us to ask, when will the next Silverpit arrive, and will we be ready? This was the hidden story of the Silverpit impact, Britain's buried crater beneath the sea. If you enjoyed this journey into deep time and cosmic catastrophe, remember to like and subscribe to Skyward Space Quest. Your support helps us bring more of the universe's hidden stories to light. Until next time, keep watching the skies.